Alright, this is for you, Steve. I wanted to go over the old management system for the 118 and just kind of show you how it worked. You asked about this tube here. This was just a basically a sight glass, so I could see where the water level was. The two towers here that you see, they were connected together here so that they would share electrolyte, so you wouldn't have too much electrolyte building up in one side and not another. In the top, one of the reasons why I built it this way is so that I could put some bronze wool on the top, which I found out that doesn't act very well with KOH. That's where you're seeing all this brown gook, and it pretty much gummed up the whole thing. But I have a screen in there. I don't know if you can see it. It's stainless steel screen, and if I did it again, I put stainless steel wool in here, and what it does is it acts to break up all the splashing that occurs. And I wanted to put the output, this is the gas output, in the middle so that I wouldn't get any splashing or anything out the tube. There's two ports here, the top and bottom. This top port is where the gas would enter in. The gas and electrolyte would enter in from the cell, so that this tube here is hooked to the top output of the cell, and this bottom one here was for the electrolyte and water going back into the cell, so that would be the input. And basically I had a tower for each side of the generator. So if you look in the video, it'll show this side hooked to the one side and this side hooked to the other side. Gas output tube, which went to the 1 gallon bubbler. And these here I used to fill both sides, and also acted as a flash port. So what I did was I took and put some like a sandwich bag around this and pushed it down into the top, which gave me a little barrier right there. So if I had a flashback, it'd blow that sandwich bag out. So that was one of the safety features. Let me show you the bubbler. Okay. On the bubbler, I have the stainless steel wool inside, again to keep the splashing down, so that I didn't have any water coming out. This is the output gas to whatever project you're working on. On this side is where I brought the input. Came in here, and let me open it. Okay. So this tube here is that's a 1-inch clear PVC, but I threaded it into the bottom of this right here. I had a let's see, what did I use? Let me grab it. This isn't the or maybe that is. I think that's the one I used. What I did is I got this at Home Depot. It's an irrigation, some kind of irrigation coupling, and I stuck it down in there and I heated it up with a propane torch, and I put some channel locks or some vice grips on there, and as I heated it up I turned it, and it cut the threads. It's pretty big. You could also use a tap if you can get one that big. But that's what I did to thread that in. Got to be real careful because you only get one chance at it doing it that way. If you heat it up too much, it tends to melt your threads too. Anyway, that's how that was done. And then on the other side of this, what I've done is I've threaded in a flash port, same as the other ones on the top of here. I've got a little plastic barrier there in case we have a flashback. It'll blow here. If it for some weird reason it got through that gallon of water, it come back and blow here and here. So had a few safety features on there. So now I'll show you the plastic, the reservoir tanks. These aren't quite as big as yours, but get the same general idea. Grab a couple fittings here. Okay. And what you want to do is your output port, you want to thread it right into there. That's thicker right there. So the electrolyte out of the reservoir tank is going to go out of here and then into the bottom of the generator. On this left side, or you can put it on the right side. If you thread the fitting right, it's kind of a line right there where this was maybe probably a molding line, but if you drill right here, right above this line where it crosses, it's a little bit thicker in that area. If you drill it there, that'll be the gas input, so coming out of the top of the generator into that fitting right there. Now on the top you're going to put your gas output, and I put it on the opposite side, so it's going to go right in there. The reason why I put it on the opposite side is because when there's a lot of bubbling going on in here, you get a little bit of splashing, especially right where the bubbles come up when they're entering the reservoir. So I put it on the opposite side to keep the splashing down. And you can stick some, if you've got some stainless steel wool, you can drive some stainless steel wool into this here, and that'll keep the splashing down. It'll keep the water in the tank. It does restrict it a little bit, but that's okay, because as soon as you build up a little bit of pressure to overcome the restriction, it's going to flow normally. Hopefully you got this type of cap from the place where you got the reservoir. This cap doesn't have any vent hole in it, and it seals really well. That's what I use on the top. So to show you how you probably hook yours up, this is a smaller one, but you get the idea. This is 59 plates. The reservoir is above this. The outputs are going, the outputs from the generator are going into the bottom. So basically each side you'd have on a different tank, and you want to drill and put a couple fittings and a piece of hose maybe, so that you can join those two tanks together so they could share electrolyte. And then out of the bottom, basically out of the bottom of the tank, it's going to go into the bottom of the cell. And what this does, as the water moves up and the gas moves up, it creates a back pressure on these and draws the electrolyte in, so it basically circulates it around. And that's basically it. I hope I was able to cover everything that you had a question on. If not, I mean, just ask me, and I don't mind doing a video. And cell's looking good. Can't wait to see it running.